Hey students, Mr. Halpern here. In this video we're going to be talking about molar volume. Okay, and molar volume is this idea that if you have a mole of a gas, in this case we're talking about gases, that it will take up a certain amount of space. And if you have more moles of that gas, it's going to take up more space. And this is the basic premise of Avogadro's law, which states that at equal temperature and pressure, equal volumes of gases contain the same number of molecules. So, let me unbolt this really quick. Wow. Not sure why this is not doing it. Unbolt. There we go. So, if we put this into a quantitative formula, it would be N sub 1 over V1 equals N sub 2 over V2. Alright, so an important note, as you see on the right hand side, when we're talking about the conditions that we call standard temperature and pressure, these are special conditions that we usually talk about when we're studying something else other than temperature and pressure. And this will help to calculate some of the other variables like volume and moles that we would want to study. And oftentimes when we say, for example, in Avogadro's law, it says at equal temperature and pressure. Usually we come up with a specific temperature and a specific pressure, and it makes it really easy to compare one experiment to another if we are talking about the same temperature and pressure. So standard temperature and pressure, as you see over here in the bubble, standard temperature and pressure is 0 degrees Celsius and 1 atmosphere. Okay, so that's something that's important to know. So if you ever see STP, then you know that standard temperature pressure 0 degrees Celsius and 1 atmosphere. So what does this mean then? So if we have more moles of something, how's the volume going to change? Well, basically what it means is that as the number of moles increases, the volume of the gas increases as well. Okay, that's really the important relationship that we're trying to make here with this new law. But that kind of makes sense. So if you take a balloon and you blow it up, right, and you put in more moles of gas, the volume should increase. Okay, particularly, obviously, if it's a flexible container like a balloon. Okay, and these boxes down here are the exact same idea, right? If you have 1 mole of gas at standard temperature and pressure, it will equal the same volume of 1 mole of any other gas. If you have 2 moles of that gas, you're going to have 2 times the amount of molecules, therefore 2 times the volume. Okay? So as you can see here, 1 mole of oxygen gas is 32 grams, right? Because there's 2 atoms of oxygen, each of them 16 grams per mole. Now if I were to look at oxygen here, if you had 2 moles of oxygen, it would be 64 grams, okay? And as a result, there'd be more volume and more pressure. Same thing, if you have 1 mole of carbon dioxide, it's going to be 64 grams, it's going to weigh that much. But the space, the volume that it takes up, is going to be exact same as the volume that oxygen gas would take up if it was 1 mole of oxygen. What about chlorine? Take a guess, right? If you have 1 mole of chlorine, it will be 71 grams, but that's not what we're guessing. The guess was how much space it would take up. Again, it would take up the same exact space, the same volume as oxygen and carbon dioxide. So the whole point is, if you have 1 mole of a gas, it's going to take up the exact same amount of space. We'll talk about specifically how much space that is. If we have 2 moles of those gases, they're going to take up 2 times that amount of volume. The other thing that I say down here, right, double the moles, double the pressure. Remember that if you have more particles, right, that you put in, instead of 1 you have 2 moles, well, then there's going to be more particles colliding with each other in the walls, so there's going to be a buildup of pressure. Okay, so this is now talking about molar volume, okay, which is the topic that we put on the top there. So molar volume is 1 mole of any gas at standard temperature and pressure occupies 22.4 liters. Okay, and this is a really important number. This is something that we will come back to time and time again with some of our problems. Okay, 22.4 is a big constant that we will address. So, and the important thing also is any gas. If I have 1 mole of oxygen, or I have 1 mole of carbon dioxide, or 1 mole of chlorine, if they're at standard temperature and pressure, if they're all at 0 degrees Celsius and 1 atmosphere pressure, they're all going to take up 22.4 liters of space. And liters is a measurement of volume. 22.4 liters is approximately about the size of a beach ball.
Hi, Mr. Halford. Are you teaching our class today? Because that actually would be really appreciated, because I'm not taking this test that we have.
Sorry about that. So, what volume would 4 moles of oxygen gas occupy at standard temperature and pressure? Well, this is kind of an easier problem, because if we know that 1 mole at standard temperature and pressure takes up 22.4 liters, then we can say that 4 moles would be just 4 times that. So if 1 mole equals 22.4 liters, then 4 moles of oxygen gas, so O2, would equal 22.4 times 4, which is just equal to 89.6 liters. Okay, so that's pretty basic. Okay, so these are a little bit more challenging down below. How many liters will 20 grams of hydrogen gas occupy? So I'm giving you grams, I'm not giving you the moles. So we need to get it into moles first, and then we have to multiply the number of moles by 22.4 liters. So in this case, 20 grams of hydrogen gas. Well, I know that hydrogen has a molar mass of 1 gram. So for every 1 mole of hydrogen, we have 1 gram. So if we have hydrogen gas, which is H2, that means every 2 grams would be 1 mole of hydrogen gas. So I would take my 20 grams, this is what you do here, and you multiply it by, you take it and you divide it by the molar mass of hydrogen gas. And you will get 10 moles. So this is 10 moles of hydrogen gas. Now that I have 10 moles of hydrogen gas, I can now essentially solve it just like the problem above, where I solved for 4 moles of oxygen gas. Okay, so now that I have 10 moles of hydrogen, what I do is I multiply it by 22.4 liters. Why did I do that? Well, I know, maybe I'll put this in parentheses, that for every 1 mole it equals to 4 liters. So then if I have 10 moles of a hydrogen gas, then I know that I just multiply it by 22.4 and I get 224 liters. Let's try another one. How many liters will 5 grams of carbon monoxide occupy? Well, I know that 5 grams of carbon monoxide, right, is what the mole carbon monoxide is. So what I do is I figure out what is the molar mass of carbon. So I know that that's 12.01 grams. And I add that to oxygen, which is 16 grams. And then I set it equal, and I divide them, and I get 5 over 28. 5 over 28. Okay, that's what my answer is for that. And then I set that equal, and I get 0.81 moles of carbon monoxide. That's what 5 carbon monoxide is. It's 0.81 moles. So now I take my 0.81 moles of carbon monoxide, I multiply it by 22.4 liters, and now I get 40 liters. That's my answer. What I would like for you guys to do is please just cross this out. You do not need to do this part right here. Okay, that is not a part of the notes. And we're done for this video. Take care.